Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Said Wafi Al Hadi bin Said Sain. My student ID is 2023454778. Today I will be presenting to you electron configurations. What is electron configurations? Electron configuration is something that describes the distribution or arrangements of electrons in atoms. It is described by using quantum numbers, that is n, which is the principal quantum number or the energy level, the L, the angular momentum or known as the shape of orbital, the M, and the magnetic of the quantum numbers, which is the orientation of it, and lastly the S. The S is the spinning direction of the electron. So why do we use electron configurations? This is used for determining the number of electrons in an atom. This is wrote by filling orbitals in order of increasing energy. This is how to write electron configurations. The number one in front of the S is the energy level, that is N, and the S is the type of orbital, that is L, and the one on top right of the S is the number of electrons in an orbital. There are three principles of how to write a correct electron configurations. The first is Aufbau principle. The second is Hund's principle. The third is Pauli principle. The Aufbau principle says that filling subshells in a specific order is the correct way to write the electron configurations. It is by filling up electrons first from the lowest energy level. This is how you write using the Aufbau principle. The energy of the 1s orbital is the lowest energy, and then you go to the 2s energy level, and then you go right next to it 2p, and then you go down left as the arrow moves 3s. The next energy level is 3p, but then the next energy level is 4s, not 3d, as 3d has more energy level than 4s. And then after 4s, then you write 3d. So in conclusion, we can write the orbital using Hund's rule by using the arrow arrangements. The Hund's rule says that the stability of electrons is the most important thing in orbital diagram. Hund's rule states that the stability of electron is most important. The stable arrangements of electron is most stable when the greatest number of parallel spins or unpaired electrons with the same spin. So why does he say that? He says that because electrons repel one another. They're charged and negatively charged. So the same charge repel one another. By occupying different orbitals, the electrons remain as far as possible from one another, thus minimizing the electron repulsion. This is how we write the Hund's rule by using an orbital diagram. We can see that the unpaired electrons of 2p is the correct way to draw the orbital diagram. The next is Pauli's principle. Pauli's principle stated that a maximum of only 2 electrons can occupy its orbitals. Electrons in the same orbital must have different spins. No electron have the same energy and quantum number. Electrons in the same orbital must have different spins. This spin can be looked as clockwise or counterclockwise. This is the maximum electrons in each subshells. In subshells of S, there is only one orbital, and in one orbital there is a maximum of 2 electrons. That is why you can see the maximum number of electrons is 2 times the number of orbitals in each subshells. In P it is 3 orbitals, in D it is 5 orbitals, and in F there is 7 orbitals. Writing electron configurations. This is used to determine how many electrons are in the atom. It is arranged according to the increasing energy. It is by filling subshells with the maximum amount of electrons for each subshells. The sum of electrons in subshells must equal to the amount of electrons in the atom. Here's an example. Magnesium has 12 electrons. Write the electron configuration and draw the orbital diagram in element magnesium. So that means we have to write according to first the off-ball rule. The off-ball rule states that filling up electron first from the lowest energy. So that means we have to write 1s, 2s, 2p, 3s, and so on. Means 1s, 2s, 2p, 3s, and so on. The first orbital, which is s, has the maximum amount of 2 electrons. The second s is also true for that. 2p, p has 6. P has 3 orbitals, which means it can carry 6 electrons. We now have 10 electrons and 2 more to go. Means the 2 more goes to the 3s. For orbital diagram, we must follow the Hund's rule. Hund's rule stated that the greatest number of parallel spins or unpaired electrons with the same spin, which means we have to write it like this. The spins counterclockwise or clockwise means that down or up. Clockwise means up, counterclockwise means down. So this is how you write it. For ions have different amount of electrons than its atom. Writing electron configurations for positive ions means that the amount of electrons have decreased, which we can see by the example of magnesium. The magnesium having from 12 to 10 electrons. It transfers 2 electrons to other atoms. Writing electron configurations for negative ions, however, means that the amount of electrons have changed or increased.